6.5, Example 1. So in this video, we're going to focus in on how to take a rational function and separate it using a partial fraction with a technique we call fraction decomposition. So previously in your math classes, you would have done problems like this, like 3 over x plus 2 plus 5 over x plus 5, and then you would have multiplied by the LCD, and you would have gotten one big fraction that had a common denominator. This would be 3x plus 5 plus 5x plus 2, and you would have simplified and put them together. Now what we want to do is take this and work backwards to separate the fractions. Okay, so we're going to rewrite f of x equals x minus 13 over 2x squared minus 7x plus 3 as the sum of rational fractions with linear denominators. Basically, we want to break it up into two pieces. Okay? So the first thing I do is I rewrite it. And then what you want to do is go ahead and factor everything, so everything is linear if you can help it. So the numerator is already linear. Linear just means that the power is 1 where the x is. And then my denominator, it's going to factor to make 2x minus 1 and x minus 3. Now our goal here is to break this up into two fractions so that the denominators are each piece, and what we need to go ahead and solve for are the numerators. So our goal is to reverse the process and break them up. Okay, so what we're going to do is we're going to solve for the a and b. So to do this, the first thing you need to do is go ahead and rewrite the function. And equals. And you don't have to use different colors. I find they help. It's up to you. Now, what you're going to do is you're going to multiply both sides by the LCD. So I'm going to multiply both sides by the LCD. So all of this is going to cancel off. So on the left side, I'm left with x minus 13 equals a times 2x minus 1 times x minus 3 divided by 2x minus 1 plus b times 2x minus 1 times x minus 3, all divided by x minus 3. Again, what I did here is I took this entire term and I distributed it to both. Okay, now we're going to simplify. So notice that in the first term, the 2x minus 1's cancel, and in the second term, the x minus 3's cancel. So now I'm left with x minus 13 is equal to a times x minus 3 plus b times 2x minus 1. Okay, now what I'm going to go ahead and do is I'm going to distribute the a and distribute the b. So I get x minus 13 is equal to ax minus 3a plus 2bx minus b. Okay, so all I've done is create a linear equation right there. Now, this step is going to seem really weird. It's really easy once you get it and kind of it'll click, but it's going to seem really weird at first. So before I start, though, I want to make a note that the coefficient in front of x is 1. Okay, so you want to look at all of your x terms. Okay, so on the left side of my equation, I have a 1x. So it's going to be 1 is equal to, on the right side, I have an a and I have a 2b. So it's going to be a plus 2b. Okay, then I'm going to look at the constants. And on the left, I have a negative 13. And on the right, I have a negative 3a and a negative 1b. So negative 3a and a minus b. Okay? So now what I've done is I've created a system of equations. And now we're going to use our old school Algebra 1 method of solving this. So you can think of it like this. 1 equals a plus 2b, and negative 13 equals negative 3a minus b. Now you can solve it however you want. I'm going to go ahead and I'm going to multiply the bottom equation by 2. So I get 1 equals a plus 2b, and I get negative 26 is equal to negative 6a minus 2b. I'll go ahead, I combine those, my b's cancel off. I get negative 25 equals negative 5a, so a is going to be 5. Okay, so I've solved for a. Now the next thing I need to do is go ahead and solve for b, so you can just use either equation. So 1 is equal to a plus 2b, so 1 is equal to 5 plus 2b. Go ahead and solve this real quick, and b is negative 2. Okay, so I've solved for a and b. Now what's really important is you do not mix these up. It doesn't matter which one you solve for first, as long as you keep consistent. So when I had my problem, x minus 13 is equal to 2x squared minus 7x plus 3 is equal to a over 2x minus 1 plus b over x minus 3. This 5, better go where the a goes, and the negative 2 better go where the b goes, right? So if you were to put b over 2x minus 1, you would have just gotten a little bit of a different answer. You would have got b equals 5. So our final answer is going to be 5 over 2x minus 1 plus negative 2 over x minus 3. And that's kind of what we were looking for there. Now on your own, I want you to try to do this fractional decomposition by yourself. So try to create the same thing that we did. I'll go ahead and I'll get you started just so I can kind of help you guys out. So I have 16 minus x over x squared plus 3x minus 10. So the first thing you want to do is factor out the denominator. So I'm going to get x and 5 and 2. And the 5 needs to be a plus and that needs to be a minus. So this is going to equal a over x minus 2 plus b over x plus 5. And again, if you want to do it this way, a over x plus 5 plus b over x minus 2, that's fine too. But as long as the right number ends up over the right denominator, you'll be okay. So go ahead, pause the video, do it either way, and then get your a and your b. So the first thing I like to do is I just kind of rewrite it like this. And then identify the LCD, which is x minus 2, x plus 5. So I'm going to multiply that to both sides. So x plus minus 2, x plus 5. So I'm going to get 16 minus x is equal to a, x plus 5 plus b, x minus 2. Notice that when this went to both, it cancels the term that it doesn't have. So if it has the minus 2, that's the one that's going to cancel, and I'm left with the x plus 5. If it has the x plus 5, the x plus 5 is going to cancel, and I'm left with the x minus 2. Okay, so I'm going to go ahead and distribute. Now, instead of writing x variables and the word constants, I just put the letter x and do one of these. And then I'm going to talk about, this is where I'm talking about my x's. So it's negative 1, a plus b. That's because it's the coefficients of the x terms. And then for my constants, I have 16, 5a, and a negative 2b. So 16 equals 5a minus 2b. And then again, it just becomes a linear system. You can solve it however you want. For this one in particular, I'm going to use substitution. So I get a equals 2 and b is equal to negative 3. This is the very important part, is that when we write our problem, we want to make sure we keep it exactly the same. So we have 16 minus x divided by x squared plus 3x minus 10 is equal to a over x minus 2 plus b over x plus 5. So we get 2 over x minus 2 plus negative 3 over x plus